Welcome to Easy BTech, your guide for BTech and beyond. Today I'll learn about the transmission line transients. Transmission line transients. The transients, what is mean by transient? Okay, the transient is nothing but, suppose assume that it is a transmission line. Suddenly if you are connect a generating station or any surge, lightning stroke, due to the lightning stroke, the surge will be induced in the transmission lines. If you close this switch, the transmission line is traveling through this transmission line. So the surge is traveling through the transmission line. Here, what we have to analyze? Here we are analyzing if there is any disturbances in the transmission line, how it will act. Okay, the surge phenomena is very important to protect our devices in overhead transmission system. How to analyze this surge phenomena? What is mean by surge and how to analyze this surge phenomena? Surge usually we will get in transmission line due to lightning strokes. Lightning strokes are switching functions. Okay, suddenly if you are connecting or disconnecting the generating stations or loads, then automatically the switching effect is like a surge in the transmission line. Okay, for example, if you are taking the lightning phenomena, a huge amount of discharge is induced in the overhead transmission system is traveling through the transmission line. Okay, how to actually this effect is very less time, less microseconds, but its impact is more. It will damages our protecting devices like lightning arresters, circuit breakers, okay, some protective equipment in the overhead transmission system. That's why we have to analyze the traveling wave transient phenomena in overhead transmission system. Okay, before going to that, we will use this one is called as a incident wave. Okay, incident wave. Okay, here we are using the term. The terms are incident wave, reflected wave, or refracted wave. It is also called transmitted wave. Transmitted wave. Okay, those terms, first we know what is mean by incident, reflected, refracted, or transmitted wave. Suppose for example, we will take a mirror. We will take a mirror. The sun rays are falling on the mirror. Okay, now this rays is called incident. I'm understanding purpose, I'm taking this simple example. This rays is called incident rays. Okay, now this mirror allows some rays through this mirror. This rays is called transmitted or refracted. Transmitted or refracted rays. Next, some amount of rays will be reflected back. Then this rays is called reflected rays. Okay, suppose for example 100% rays are fall on the mirror. It will allow only 40% of rays through the mirror. Remaining 60% is reflected back. Therefore, we can say that the transmitted or refracted rays transmitted is equals to incident plus reflected. Okay, incident plus reflected. Incident is 100%, reflected is it is reflected back. That's why I'm taking minus. It is in this direction. That's why it is plus, it is minus. Therefore 100 minus 60%, we get 40% is the transmitted or refracted. Okay, I hope you understand what is mean by transmitted, reflected or refracted from this example. Okay, now we will go into the subject. Here we are analyzing the same concept. If surge will be induced in the transmission line, it will traveling through the transmission line. Here we are taking some conditions. If transmission line is connected to a resistor, how much wave will be transmitted through the resistor and how much wave will be reflected back. This is the case 1. In case 2, the transmission line is open circuited. It will offer infinity of impedance. Then how much is transmitted, how much is reflected? This is case 2. In case 3, the transmission line is short circuited. Sorry, the transmission line is short circuited. The transmission line is short circuited. This is case 3. Then how much is reflected, how much is transmitted through the short circuit. In equation 4, if you are connected this overhead transmission to underground cable, I'm representing the surge impedance of underground cable is ZC, the line surge impedance is ZL. If you are connecting a transmission line to underground cable, then the surge is how much is flowing through the cable, how much is reflected back. Next, if you take the junction, okay, it is a T junction, it's having Z2 impedance, it's having Z3 impedance, it is Z1. How much, if you are having a junction, how much is transmitted, how much is reflected? In a sixth case, we will take the transmission line connected to the inductance. The transmission line connected to the inductance, then how much amount of surge is flowing through the into the inductance and how much is reflected back. And I'm taking the another case, the transmission line is connected through a capacitor. How much is transmitted, how much is reflected back? Those the cases we will discuss here. This transient analysis is very important to analyze, okay, how much voltage is flowing through the our operators, because we are having isolators, lightning arresters, circuit breakers and other protecting equipments. Okay, if this due to the surge phenomena, a huge amount of voltages are available across the our protecting devices, our protecting devices. Then we have to design that protective devices to withstand that huge amount of voltages. That is one thing. Next one is automatically the span of this surge voltages is very less. Okay, it will after some deflections it is automatically die out. But initial analysis of the wave in a fraction of seconds, in fraction of microseconds, is very important to protect our devices. It is completely depending upon the surge impedance. Okay, we will see how much a waveform will be transmitted through the devices for the following 7 conditions, how much reflected back, how we can evaluate these transients. Okay, thank you very much for watching.